There is no such thing as a completely risk-free life. It is both a physical and mathematical impossibility to remove every danger from our existence. In fact, we willingly accept unnecessary dangers every single day. We might choose to eat foods heavy in cholesterol or text while driving down the highway. To understand how scientists measure these everyday dangers, we have to isolate two specific terms. The first is a hazard. A hazard is any environmental factor or human choice that can cause injury, disease, or economic loss. The second term is risk. Risk is the actual statistical probability of suffering harm from that specific hazard. We cannot remove hazards from the world around us. Our survival relies entirely on our ability to accurately calculate and manage these invisible probabilities. In our daily lives, human health is constantly challenged by 5 overlapping fronts of hazards. First, we face biological hazards. These stem from over 1,400 distinct pathogens, which are disease-causing microorganisms like bacteria, viruses, and parasites. Second are chemical hazards. These arise from harmful compounds lingering in our air, water, and soil, as well as human-made products like heavy insecticides. Third are natural hazards. These encompass catastrophic environmental events like forest fires, earthquakes, floods, and severe storms. Fourth are cultural hazards. These are the built-in dangers of our societies, ranging from poverty and criminal assault to notoriously unsafe working conditions. And finally, lifestyle hazards. These are the voluntary choices we make that harm our own health, like maintaining a poor diet or choosing to smoke. Because we navigate these 5 overlapping categories every day, society relies on a strict scientific pipeline to separate minor inconveniences from true statistical threats. Scientists quantify these dangers through a process called risk assessment. This is a statistical method used to estimate the exact amount of harm a particular hazard might cause. In this process, scientists abandon descriptive adjectives entirely. They express danger strictly through the lens of mathematical probability. This diagram shows exactly how that looks in practice, using the textbook example of smoking. If someone smokes a pack of cigarettes a day, their lifetime probability of developing lung cancer is exactly 1 in 250. That probability can also be expressed as a percentage, giving an individual a specific statistical chance of developing the disease over a typical 70-year lifespan. The rule of this assessment is straightforward. The higher the probability of the harm occurring, the greater the statistical risk to the individual. This chart maps out exactly how scientists structure the calculation. Step 1 is hazard identification. What exactly is the hazard? Step 2 measures the probability of risk. How likely is the event? Step 3 outlines consequences, the likely damage to human health or the environment. This rigorous assessment gives us a clear mathematical picture of the danger at hand. But gathering the data is only half the battle. Data alone does not keep society safe without human action. That required action is called risk management. This is the critical phase where scientific data collides with real-world decision-making and economics. Moving to the right side, management starts with comparative risk analysis, weighing the threat against known risks. Next, they form a specific risk reduction strategy. Finally, they determine financial commitment. Society must decide how much money to spend to fix the problem. Risk management requires a difficult balancing act. It involves weighing the statistical cost of human life and damage against the concrete financial cost of prevention. Living a perfectly zero-risk life is a myth. But suffering from unchecked hazards is not a mandatory condition of human existence. Applied properly, risk management results in tangible societal defenses. It generates protective laws and safety engineering that actively saves lives on the road every day. It also drives critical medical advancements. We successfully combat biological risks because we assess them accurately and deploy the financial commitments necessary to fight back. By identifying the 5 major fronts of hazards and applying the mathematics of risk assessment, we can weigh the true costs of our choices and build a safer, longer-lasting society.